Hello, my name is Wyatt Tagg. I am an aspiring pilot, and I have been working on my pilot's license for the last 4 years, wanting to become an airline pilot so that I can continue to do that work in the future. I have been given the opportunity to see many advancements in technology in the aviation industry, and I'd like to share some of those with you. In recent events, we have seen that many plane crashes in the airlines have been happening between the Toronto Delta crash on the runway as it rolled over, and the American Airlines and Black Hawk crash during the approach. And that has definitely left a lot of people scared and worried about flying on airlines in the future. And what can we do to prevent it? I wanted to talk a little bit about how today I think that you should feel confident in flying on an airliner. And most of these incidents are due to pilot error because technology has been greatly advanced so that even in future generations, as it's continuing to grow, we can feel safe in flying on these airplanes. One of the first inventions, if I could remind you of how we've already had Teslas self driving. Teslas have been able to self drive, self detect traffic, obstacles, and turns in the road so that we can safely drive you to your next destination on the highway. In airplanes, we have autopilot. Autopilot has been used in the past 100 years using gyroscopic instruments to maintain altitude, direction, and maintain that straight and level flight for our pilots. That has greatly reduced the pilot fatigue and pilot workload so that we can focus on other parts that are very important during the flying procedures. Another another technology that has been used in the last 60 years is Autoland. Autoland is a feature inside mostly commercial aircraft, and these commercial aircraft are able to maintain not only their direction and altitude during a descent into an airport, but they're also able to manage their throttle and thrust so that it will reduce speed as you get closer to the airport and maintain that speed and maintain the aircraft in a straight and level flight during abnormal conditions, so that mostly when autoland is used is during low level clouds, rain, low visibility. And so this autoland feature is able to safely bring the plane down to a slow speed and land it safely on the runway with pilot supervision. With these inventions, we're seeing that aviation crashes have been diminishing in this is only a graph of the last 40 years, but in the last 100 years, that has been a steady line. And in recent years, as you can see, in around 2020, we're able to see that it is greatly reduced in the past couple of years due to these advancements in technologies. I kind of wanted to show another graph here for the amount of fatal airliner accidents per million. So every million flights that happen in 1970, there were 6 fatal aircraft accidents. But in 2020, we have, you can do that calculation a little bit, and it's almost every 2 million airliner flights, there's one fatal aircraft accident. For the second point I wanted to bring you towards was how important and when the most crashes happen. This graph shows a little bit how landing is the most dangerous phase of flight. Landing has the most parts, and it's where the most congestion of aircraft are. As you can imagine, up in the sky, there's just so much of it to be around. You don't have to worry about too much traffic in the air. But when you get in towards landing, we do have the situation where we have multiple aircraft trying to land on this one strip of runway. In international airports, it's a couple more strips of runway, but that's why we have air traffic controllers. And so during this phase of landing, the technology that we use is through radio signals. And so these radio signals are called ILS, RNAV, VNAV, ILS's instrument landing system, and our RNAV and VNAV systems are pretty close to the same thing, where that uses GPS. So aircraft use GPS, ILS, and these RNAV frequencies so that we can safely glide down towards the runway in low visibility. This is how that auto land feature that's how that auto land feature works. It takes into account these glide paths. As you can see, this is kind of the simplest diagram I could show you, where your plane will follow that glide path through the radio frequencies that it's using from a tower that is on the airport, and it will follow it in that intersection. And so the pilot is supposed to watch and manage and make sure that the correct radio frequencies are being used so that the aircraft will follow those. And pretty much the plane will take you all the way down to that minima. In commercial flights, that minima is almost all the way to the runway. And in some cases, it is the runway. I wanted to show you a little bit what the pilot point of view is. So the pilot point of view, you can see the bright green labels the bright green diamond on the right altitude. As that goes up and down, you want to keep that diamond level in the middle. And then the green line in the bottom middle, you will be keeping on that localizer, and that middle bar swings out to the left and right so that you can turn to make sure you stay in that center path. And these instruments today, they are very nice so that they can even, if you put your little yellow cursor in that magenta cursor above it, it'll take you all the way down to that middle crosshair. And this is something that is not just for commercial airlines, but if you happen to go up with a friend and go in for a general aviation flight in small little prop planes, which is where most accidents happen. They're not fatal very often, but they do occur more than airliners because they are with younger, less experienced pilots. And so the super cool thing about these small planes is that there's a lot of inventions going on inside this company called Cirrus. Cirrus is a general aviation brand. They have expanded a little bit to have their first jet, so they have a little bit of a play in corporate aviation. And that jet is there on the left. That is the Vision Jet. The Vision Jet uses it's called a safe return auto land feature. And so say you're in a passenger and you're sitting in the back, and for some reason your pilot is incapacitated, has some sort of medical emergency, and you have no idea how to fly that plane. Cirrus has been able to invent this for small aircraft. Whereas auto land features in commercial aviation, it still needs a pilot, still needs all those people to maintain that safe conditions. The Cirrus Vision Jet is able, just by a push of the button, to safely return to the landing field without any monitorization of the passengers. The passengers can talk to ATC, air traffic control, to make sure that they're safe and be guided through that process, which they don't need to, but the aircraft will communicate emergency frequencies to air traffic control so they know to get all the traffic out of that area. That safe return feature will also bring them to a safe stop on the runway in a landing configuration. So it will land with its wheels down like a normal landing. No issues. In their smaller prop planes, which is becoming a very common and a very amazing invention that has saved many lives, is the parachute system that they have on their planes. It's also in the Vision Jet just in case, but in their prop planes, you're able to see an actual deployment of that parachute. It's not a parachute for individuals like us, it's for the airplane, so that the individuals can stay inside the aircraft where it's safe, and they're able to safely fall down to the ground. And that is why aviation has many technologies keeping aviation safe and is making these skies safer, not just for the pilots, but for all the passengers inside commercial aviation. Thank you so much.